Today we are going to see analysis of variance. Analysis of variance is a technique used to test equality of means. When more than two populations are considered, in Z-test and T-test, we consider only the equality of two population mean. If there are more than two populations, for testing the equality of their means, the analysis of variance method is applied. We now proceed with the analysis of variance with the different classifications. 1. Samples are independently drawn from the population. Second point, that populations are normally distributed. Third point, the variance of all the populations are equal. Now we consider two types of analysis of variance. Type 1, one-way classification. Type 2, two-way classification. In one-way classification, observations are classified according to one factor. This is exited column-wise. In two-way classification, observations are classified according to two factors, one column-wise and other row-wise. So we are going to see one-way classification. A set of n observations classified in one direction may be represented as follows. x1, x2, etc. up to xn. This one is x11, x12, etc. x1r, x21, x22, etc. x2r, xn1, xn2, etc. up to xnr. Here mean x1 bar, x2 bar and xn bar. x bar the whole bar is equal to x1 bar plus x2 bar plus etc plus xn bar the whole divided by number of terms n. Then between column sum of squares denoted as SSC, sum of squares column, that is equal to summation of j xj minus x bar the whole square. Within column sum of square SSE, that is equal to double summation xij minus xj bar the whole square. Total sum of square denoted as SST, that is equal to double summation xij minus x bar the whole square. Also it can be shown that SST is equal to SSC plus SSE. That means the addition of between columns sum of squares and within column sum of squares. In each of these sum of squares is divided by the corresponding number of degrees of freedom, we get mean sum of square. In table form, Anova table, source of variance, sum of squares, degrees of freedom, mean sum of squares, variance ratio. Here between column, next within column. Between column sum of square, within column sum of square, degrees of freedom, C minus n minus 1 and this capital N minus C, mean square within column is SSC divided by n minus 1, SSE divided by capital N minus 1. The sum of ratio F test equal to MSC. Otherwise, is equal to MSE divided by MSC. F ratio should be calculated in such a way that F is greater than 1. The total SST, the total sum of square capital N minus 1 shortcut method. Step 1, find capital N, the total number of observation. Step 2, find T, total of all observation. Find 3. Find t squared by n, the correction factor. Then calculate fourth point. Calculate the total sum of square. Total sum of square, that is equal to sum of x1 squared plus sum of x2 squared plus etc. minus t squared by n minus corresponding correction factors. Fifth step, calculate column sum of squares. That is sum of x1 the whole squared by n1 plus etc. plus etc. minus t squared by n. Hence n1 is the number of elements in each column. Step 6, the null hypothesis and alternative hypothesis are started. That is h0 is mu1 equal to mu2 equal to mu3. The population means are equal. Population means are equal. The alternative hypothesis mu1 not equal to mu2 not equal to mu3. It's not, population means are not equal. In two-way classification, of analysis of variance, we consider one classification along column wise and other along row wise. Procedure: define hypothesis. There is no significance difference between column means. As well as between row means. The null hypothesis, we can say there is no significant difference between column mean as well as row mean. The alternative hypothesis, there is significant difference between column mean or between row means. Then step 1, find n. Step 2, find capital T. Step 3, find t squared by n, correction factor. Step 4, total sum of squares. Step 5, column sum of squares. Step 6, row sum of square, SSR. Then step 7, total sum is equal to SSC plus SSR plus SSE. This is SSE. Then ANOVA table. Sum of variation sum of squares degrees of freedom, mean sum of square and variance ratio. Here between column, between rows, and residual, that is error. Sum of square, column sum of square, row sum of square, and SSC within column sum of squares. Degrees of freedom, small n minus 1, r minus 1, capital N minus C minus r plus 1. Mean square, MSC equal to SSC by minus 1. MSR equal to SSR divided by r minus 1. That is equal to SSC divided by n minus C, that is n minus n, small n minus r plus 1. This is, we can say, n. The ratio FC equal to MSC divided by MSC divided by MSC divided by MSE. FR equal to MSR divided by MAC. The F ratio FC and FR should be calculated in such a way that FC and FR greater than 1, then only it is possible to compare this ratio within the table values.